Okay, in this problem here, we are given a reaction. We're given information about the rate law indirectly. We are given the information that the rate is first order with respect to A, okay, second order with respect to B, and then we're asked to identify which test tube would have the fastest initial rate. So let's write the rate law. Rate is equal to K times concentration of A, first order, so raise to the first power, times B to the second power because it's second order. So that's the same thing as saying K times A times B squared. All right? So which of these test tubes would have the fastest initial rate? We're given concentrations. We're not given K, but we can just plug it in and figure out what the rate is using the variable K. So let's do A. The rate is equal to K, which sure is unknown, times A, which is 0.5, times the concentration of B, which is 4 molar, right? Squared. Okay, so that's K times 0.5. What's 4 times 4? That's 16. That's equal to 8 times K. All right. We repeat the process for the different test tubes. For B, over here on the right, we've got A is 2. B is 1.0. Okay. So we have K times 2 times 1 squared. 1 times 1 is just 1. 2 times 1, so that's 2K. That's definitely lower. For C, we've got 1 and 2. Rate is equal to K times A is 1. B is 2.0. Okay. So we have 1.0, and we have 2 times 2 is 4. Okay, so in this case, we have 4K. Okay, that's lower. It looks like 8K is the winner so far. Let's plug in D. Rate is equal to K times A, which is 4, 0.5 squared. So that's K times 4.0. Okay. And what's 0.5 times 0.5? That's 0.25. Okay, or 1/4. So 0.25 times 4 is 1. 1 times K. Okay, or just K. So it looks like 8K, whatever K is, this is going to be the largest. So the correct answer here is A.